All right, question 3. Note how this sum of I cubed plus n plus 1 cubed is equal to the sum of I plus 1 cubed is equal to this thing cubed. Yeah. Use this result to obtain a formula for the sum of I squared. All right, that is not pretty. Let's see what we can do with it. All right, so they give you some stuff without proof that you're allowed to use. The sum as I goes from 1 to n of I cubed plus n plus 1 cubed is equal to the sum as I goes from 0 to n of I plus 1 cubed, which is equal to the sum as I goes from 0 to n of I cubed plus 3i squared plus 3i plus 1. We are to use the fact that all of those are equal to then find a formula for the sum of I squared as I equals 1 to n, and then compare with the formula given. Well, if I multiply this out, I plus 1 all cubed, all I get is this, right? The binomial theorem gives me that right away, that this is exactly equal to this. So that this is nothing special. The fact that these two are equal is nothing special. That's just the binomial theorem. But the fact that this equals that, that's the more interesting thing. So let's start with this left-hand side. Let's see what this actually is. If I take the sum as I goes from 1 to n of I cubed plus n plus 1 cubed. Yeah. Now that, okay, so you got to be a little bit careful here. The sigma notation is around just the first term, it looks like. When they do this in the book, they put a bracket around this and they put a bracket around this, indicating this, the sigma notation is of everything in the brackets. But here there's no bracket. It's not the sigma notation of the n plus 1 cubed is not in the bracket. So I'm gonna assume it looks like this. It's the sum of I cubed. Hey everybody, let's take a break from the example for a sec. The example I'm doing here is really just a single example, and there are literally infinitely more problems you can run into on a discrete math exam. And odds are good you'll run into problems you've never seen before and be expected to apply what you know to solving them. But if you don't understand the content, you have no hope. So if you're taking a university, if you're a student taking a university discrete math course, and you're serious about not just getting a good grade, of course, yes, getting a good grade, but if you're serious about understanding the content, then go ahead and click the first link in the description down below and book a free call with me. Now, back to the example. All right, so let's give it a shot. What we're given is that is equal to this. Now, the way sigma notation works, the way sums work, is I've got a sum of this term, and then when I is 1, the next term, when I is 2, the next term, but that's each of those terms is 4 things added together. And if I have 4 things added together, 1 plus 2 plus 3 plus 4, and then another 4 things added together, 5 plus 6 plus 7 plus 8, and it keeps going, I can reorder the addition any way I want, because addition is addition. I can reorder addition any way I want. It's commutative, it's associative. And so what I can do is I can separate this out to be all the first terms added together, all the I cubes added together, plus everything else added together. And so what I can do here is I can split this off to be the sum of I cubed plus the sum of everything else. See how that works? Because this is just a bunch of things added together. All I did here was I reordered the addition. I added all the first terms first, and then added everything else afterwards. Okay. So now these almost cancel. Oh, in fact, they do. Because when I is 0, you just get 0 cubed, which is 0. And so this is the same thing as I goes from 1 to n, because when I is 0, this is just 0. And so these directly cancel out. So subtract those on both sides.
Hey guys, if you are looking for help with learning discrete math or proofs, I know they're tough, then make sure to subscribe, as I'm literally going to be posting every example I have here for free on YouTube to help you learn and understand discrete math proofs. Back to the example.
And what I get is n plus 1 cubed is the sum as I goes from 0 to n, 3i squared plus 3i plus 1. Well, I can now separate these things in exactly the same way. And add them up all separately. And this is almost the one I'm interested in. We'll get to that in a sec, but the other ones I actually know. Here, this is the sum of 3i as I goes from 0 to n. Okay, well, first off, again, when I is 0, this goes away. So it's just I is 1. But what this is doing here is I'm taking every single term here, the i's, and I'm multiplying by 3. Well, that's the same as just multiplying I by 3. Right? Here I'm adding 3, 6, 9, 12, 15, dot, dot, dot. Now I'm adding 1, 2, 3, 4, 5, 6, and multiplying the whole thing by 3. Same thing. Over here, we actually know this one. The sum as I goes from 0 to n of 1. The 1 doesn't change depending on I. When I is 0, we get 1. When I is 1, we get 1. When I is 2, we get 1. When I is 3, we get 1. Regardless of what I is, this is always 1. So how many 1s do we have? How many 1s are added together? Well, n plus 1 of them. So that's just n plus 1. Same thing over here. I can pull the 3, just like I did there. I can pull the 3 out. And now I have a formula involving what I'm interested in. This is now what I was asked to solve for. This, I've got 3 times the sum of I. That's actually the first induction proof we did. The first induction proof we did was the sum of I as I goes from 1 to n is n times n plus 1 over 2. First induction proof we did. And so now we just have to solve. So what I'm interested in, I goes from 0, I guess, 1, doesn't matter. 1 to n of I squared is the n plus 1 cubed is over there. Subtract from it this thing, 3n n plus 1 over 2. Subtract from it this thing, n plus 1, and divide the whole thing by 3. And when you simplify that down, move it up a bit. And when you simplify that down, you'll get the nice formula that, yeah, you got a nice factorization here. N plus 1 factors out of all of them. Well, maybe we'll do that. Let's just finish off. So I pull out an n plus 1 out of everything on top there. What do I have left? N plus 1 squared minus 3n over 2 minus 1 over 3. I can't really see a nice way to simplify that other than just multiply it out. So let's do it. I'll get a common denominator there, 2n squared, n squared plus 2n, so times 2, 4n plus 2 minus 3n minus 2 all over 2. And combine like terms, we get 2n squareds plus an n, and that's it. The 2's cancel, all divided by 2. And factor out the n and the 2, and what's left? n plus 1, 6, and I factored an n out of here. All I have left is then 2n plus 1. And there it is. That's the nice formula given in the text for the sum of I squared.
Hey, thanks for watching. Remember, what I've explained here is just a tiny, tiny example in the literally infinite space of problems there could be that you'd run into. So, if you're interested in really understanding this content, getting a good grade because you understand the content, go ahead and click the first link down below and book a free call with me, and let's talk about if I can actually help you do well in this course.